All right, so we're gonna make a start, and before we start, we're gonna have two revision questions. The first one is going to be, um, what is an IPO chart? That's the first question. What is an IPO chart? Anybody?
Search does input, the process, and the output.
For
Anything like an item, like if you go and buy an item at the supermarket,
mm-hmm,
and you want to know the total cost,
mm-hmm.
you can input the cost for the item, the two items. You can show the process, like adding the two, and then the output can be the total.
Good, good, very good. But in line with what we are learning, what is the IPO chart for? What are we creating it for? What builds upon the IPO chart? What's the next step after the IPO chart? No one? So we're making it for the algorithm. Remember I said the IPO chart is basically step 3.5 and designing your algorithm. So IPO chart would fit somewhere between here. So you design your IPO chart, and as you said, the IPO chart is to indicate the input, process, and output. But for the algorithm, it's indicating the input, the processing, and the output for the algorithm that you are designing. That is what I was the last part I was looking for. All right, good. Final question. Um, what is the difference between a flowchart and a pseudo code? What is the difference?
The pseudocode is like written standard English with
Mm-hmm.
different steps. And the flowchart is more of a picture kind of diagram thing
Good.
with shapes and so on.
Right. That's correct. So, and yeah, so as you said, the flowchart is a more of a pictorial method using diagrams, and the pseudocode is more of a writing these steps in English, plain English. And they're both a representation of the algorithm. They're ways of representing that algorithm. So it's the same step by step guide. Good. That's a recap of some of the things we learned last week. Now we're gonna continue with chapter 9.2, and we're gonna learn about what are variables and constants. So if you guys can remember last week, when we were creating the IPO charts, I would have mentioned that, let's look back at these example here. I would have mentioned that these here are called variables. They're what we use to store our input. Because whenever we have to work with the data, numbers, a word, it has to be stored somewhere. And where we store it is what is called a variable and a constant. They're two different methods of storing data. So let's explain how data is usually stored when it is input. A variable or constant is an area or space in memory that holds data that a program might use or manipulate. Anybody has any idea what kind of memory is being mentioned here? What memory is being mentioned here? Something you would have learned in third form. What memory does the computer have? What memory do we call that? It's a type of memory that all computers must use in order to send instructions to the CPU. Starts with R.
Sir, is it a RAM?
I'm barely hearing you, Oceana.
Sir, is it RAM?
RAM, yes. Anybody remember what RAM stands for?
Random access memory.
Very good. Random access memory. So this is something you guys need to remember. How a computer basically works. I'm trying to find a diagram right now. Yeah, this is the layout of a motherboard. A computer basically. And where you see AMD, here, that's the CPU. So where is color? White. So this here is the CPU. Now here is memory at the bottom here. This blue stuff, this blue slot that's seen here, or RAM. That's RAM. And somewhere, where is it? Somewhere at the edge here, your hard drive is going to make a connection. This is your hard drive. It's going to make a connection to the computer, like that. So, understanding how the computer works is that data comes from the RAM, comes from the hard drive. Or you could type it in on the keyboard. It could either already be on the hard drive or you type it in on the keyboard. Now, the CPU has to process that data. Remember, the CPU does all processing, central processing unit. So, that data, whether it's coming from the keyboard, say for instance the keyboard is plugged in somewhere over here next to the USB port. We have a keyboard over here plugged into the USB port. Now say we type in on the keyboard. Let me make this a bit larger. Yeah. Say we type in data. The data has to travel from that USB keyboard to RAM. And it has to be stored in this memory. When the CPU is going to process that data now, it's going to tell the RAM, look, I would like to have that data. So data goes back and forth like this here between the CPU and the RAM. So that's how the CPU gets data in order to function, in order to work. That's how your computer right now is working. Data has to first be stored in memory in order to go to the CPU. Even though it's already on the hard drive, the same process. The data has to come from the hard drive and be stored onto the CPU. Sorry, the RAM. and then it goes to the CPU to get processed. Think you guys clear on that?
You can explain it what?
All right. So, in order for anything to be done on your computer, like for instance, the fact that I have Microsoft Word open, I have Chrome open, I have Internet Explorer open, the fact that I can move this cursor, the CPU has to process all of that data, the central processing unit. It processes everything, controls everything, directs everything. That's the brain. Just like how your body has a brain, this CPU is the brain of the computer, controlling everything. Now, in order for the CPU to know what to process, what to control, what to do, it has to get data. Where does it get the data? It gets it from the RAM. It gets it from the memory. So it goes down to the memory, this blue slot here, the RAM, pulls the data. Where does the RAM get the data? The data can either come from the keyboard, you type it in, and it gets stored into RAM. Or it could already be on your hard drive. It could already be on your flash drive. And it goes to RAM. So whenever the CPU needs it to process it now, it simply pulls the data from the RAM to the CPU and then processes it. Then sends it back to the RAM if it needs to store it again. So this here is your temporary storage, and this over here is your permanent storage. Your hard drive is going to be your permanent storage here. Was that clear?
Yeah, and where's the read-only memory?
The read-only memory, that's going to be like a chip looking like this here. Let me change the pencil. Yeah, a chip looking like this one here. A little black chip. Stored on the um, a small amount of storage that is going to be used to store the BIOS, which is basically some settings that helps the computer to know how to start up and check all the check the RAM, check the CPU, check to see if everything is working. That's basically used to start up the system and ensure everything is working. Any questions? Any other questions? All right. Yeah, so that's a basic idea as to how your computer works. Any computer, whether it's your phone, whether it's a smartwatch, whether it's a laptop, whether it's a desktop, they all function with this basic concept. Data has to go into RAM, and the CPU pulls the data from RAM to process it. That's how all computers work. So it's basically the IPOS cycle, the same cycle it's following. You input the data has to be processed, you're going to output the data, and the storage could either be the permanent storage or the temporary storage. So, going back to what we're looking at, a variable now or constant is an area or space in that memory or this RAM here. So a little piece of this RAM here is where the variable is going to be stored. And that is going to hold the data that the program is going to need to operate, to function, to manipulate. So if it's like, for instance, a calculator, and you enter the number one, a small area in the RAM is going to be used to store that number one, like that there. So that is what a variable or constant does. It stores the data for the program to work. Now, it could either be text data, like letters, symbols, or so on, or it could be numerical data, number data. Either one of those data. Now, what is the difference between a variable and a constant? Um, what does the word constant mean? What does the word constant mean? Nobody knows what the word constant means?
Sir, like a number.
No, the word in general. The word constant.
Sir, something that doesn't change.
Right. So the word constant means something that does not change. So does not change. That's what the word constant means. Now, what does the word variable mean? What do you think that means? Just the word itself, variable. Good afternoon.
That it could change.
Right. That's simple. It changes or it varies. So that's how we could remember the difference between a variable and a constant. Now remember, they're both used to store data, but one will keep the data all the time, the same data all the time, and one will be allowed to change its data over time. So a constant is a type of variable where the value does not change for that algorithm. So it's like what we were doing in spreadsheet. If you guys can remember, sometimes in spreadsheet you wanted a cell to remain the same, so you named that cell. So similarly, in programming, certain values, we want to keep that particular value. And we have a type of storage called a constant that is going to keep that value. So for example, pi, the value of pi, that's going to be a standard value. So instead of us keep typing in 3.14 or whatever, we store it as a constant and we keep using this name. So for instance, we're going to say pi is equal to 3.14. So instead of saying every time we got to use the value pi, we type in 3.14, we don't do that. We just use the word pi. Pi. Every time we need to use the value 3.14, we use the word pi. That was already stored into that constant there. Value added tax, VAT. That doesn't change. It might change depending on the government or whatever the case may be, but it generally does not change. So it might be a standard value. For us, a standard 14% all the time, or 0.14. One thing to note, especially in programming, we do not use the percentage sign. Anytime you're going to deal anything with percentage, because if you notice here, we have 0.175. It's not in a percentage value because we do not treat the percentage sign as percentage. It's not a form of calculation called modulus. Anybody ever heard of that? Modulus? No? Alright, we're going to learn about that later on. But just take note that we do not use the percentage sign for percentage, especially in programming. Anytime you have to use a percentage, you must convert it into the decimal format. So that's divided by 100, you get your decimal format for it. And you use that for your calculation. So, going back, we're looking at what is a constant. A constant is going to store that one value throughout the program. Whereas a variable, as we said, it changes, it varies. So for instance, we don't want it to keep that value. So for instance, take off draw, Yeah. So for instance, say we have a program, and we say discount is equal to 5%, 0.5. So I'm giving you an example there of a constant. We have a discount at a price of zero, at a percentage of 5%. Is um is that 5% or 50%? 0.05. Am I correct? Yeah, supposed to be that. That's supposed to be jumping at these answers. Um, 5 divided by 100. Yeah, 0.05. Yeah, good. So we have a discount 0.05. That's 5%. Now, so I'll put this side here. Constant, and we have price, which we would not know the value of because it's a variable. So say for instance, we do a calculation, we say price multiplied by discount. Remember, the price could be anything. So we don't want it to be a fixed price because it could be the price for a cheese stick, the price for a shirt, the price for a pants, whatever the case may be. So this could be 500 times 0.05, or it could have been 700 times 0.05. So the discount part is always going to remain the same because that's constant. We're using a constant to store that value. It's going to keep that value. But the variable is allowed to change. Anytime the person enters a new price, it changes. Any questions? Any questions? Any comments?
No, sir.
All right. Good. So that's the difference between a variable and a constant. Now, the values in a variable can change. As I mentioned, the value in a variable can change throughout the algorithm as data is processed. Examples of variable names are number and total. Each variable is given a name. So each variable is given a name because you must identify it. Just like how in spreadsheet, each cell was given a name. Similarly, each variable is given a name so that we can identify it. So, do you think two variables can have the same name? And two variables have the
No,
same
sir.
name? No, they
No,
cannot
sir.
have the same name. Good, very good. Because that will conflict with each other. So each variable is given a name so that you can assign values such as numbers or text to them and refer to them later to read the values. So instead of you, once again, as I mentioned, typing in these values, you can store it into a variable and have that variable make use of those values. Now, variables typically store values of a given type, and some types are below. So this is the important part here to take note. We have variables typically store values of a given type. So just like in spreadsheet, once again, how we had different data type. So how we went to the cell. So this is a cell, the cell had a name, and if we type in 55, we could say that 55 is a number and it is represented in that manner. Or we can say 55 is a currency, it's being represented in that manner. Or we can say 55 is a date and it's being represented in that manner. Similarly, the variables have types, and the type indicate what type of data is going to be stored in that variable. So it's a security mechanism also, because if you only want a certain type of data to be accepted, then only that will be accepted in the program. So I'll give you an example after we go through each data type. So these two are similar, integer and real data type. They're both for numbers, but integer whole numbers or positive numbers. So the integer is mainly for whole numbers, only whole numbers, whether it's a positive or a negative number. So notice some examples on this right hand side here. It will not store any decimal numbers. So for instance, um, if you want to accept um, if you want to accept somebody's age, you're going to say that variable age is going to be an integer data type, because you don't want to accept that the person is what, 7.1 or 10.6. That doesn't make sense. We just want the fixed whole number value, whether the person is 7 years old, 10 years old, 21 years old, whatever the case may be. So by setting that variable age as integer, it prevents the person from typing in a decimal number. That's the purpose of the data type, to ensure that the person types in the correct data, that the correct data is being used. So integer does not use any decimals, only for whole numbers. And that means the real includes fractional or decimal based numbers, whether that is a positive or a negative number, as you can see here. So basically, the real data type can store any form of numerical value, well, represented in these manner. Now, the character and the string are similar also. Let's look at the character first. Now, a character is basically a single character. Only a single character can be stored. And a character is simply a letter or a symbol. A letter or a symbol. A letter, a punctuation. So as you can see on the right hand side, the letter G, the letter B, or the symbol asterisk. It's only going to store one single character. Not two, not three, one single character. If it's just a question mark, that is all it's going to store. So, for instance, if you have a question like, let's see, marriage. You have a question like marriage, then you could limit it to Y for yes, N for no. And make it simple there instead of the person type in anything else unnecessary. Now, a string, the string data type, is when you're going to have a collection of characters. So now, if you want the person to type in a whole sentence, or type in their name, their first name, their last name, their address, whatever the case may be, you go with a string data type. So, for instance, you have address equal string. And that way now the person can type out the entire address into that string, into that address variable. And the final data type, the Boolean. The Boolean was a similar example to the yes and no question of marriage. It's when you only have two values. When you're only going to have two values. So for instance, true or false, yes or no, male or female, whatever the case may be. So a Boolean data type is when you're given the person two options and they can only choose between the two. So yes or no, true or false, whatever the case may be. So once again, a variable is what we use to store data. Now we have to indicate what kind of data is going to be stored into that variable. And we do that by indicating the data type. We have 5 data types that we are going to consider. There's actually more, but as if you go deeper into programming, but for basic programming, we're only going to need to remember these 5 types of data. The integer is only for whole numbers. The real, whole numbers and decimal numbers. Character, one single character, whether that's a letter or a symbol. String, a collection of characters, words, phrases, whatever the case may be. And a boolean is when the person only has 2 options. So if there's a question like, are you single? Yes or no. Are you a father? Yes or no. Are you happy? True or false. So those are the data types there. Any questions? All right. Give me a second. All right. So let's see if we're clear on the data types. Let's see if we can answer these questions here. So the first question, what type should you use to represent the average grade for a course? Now, int is integer. That's just short for integer. Integer that we have here. Int is short for integer. Double is another word for real. So double is another word for real. Boolean, we already learned was Boolean and we know was string. So what type should you use to represent the average grade for a course? Which one? What's your answer?
Double?
Stephanie says double. What about the rest?
Double, sir.
Double. All right, let's check double. Check. Correct. An average is calculated by summing all the values and dividing by the number of values. To keep the most amount of information, this should be done with decimal numbers. So use a double or a real. Good. What type should you use to represent the number of people in a household?
Integer?
What about the rest? Agree, disagree?
Integer, sir.
All right, integer. Because we can't get half a person, right? Technically we can, but still a person. The number of people in a is a whole number, so using integer makes sense. Next one. What type should you use to hold the first name of a person?
String?
String. Because that's a collection of characters, right? You want the person's name. String. Strings hold sequences of characters like you have in a person's name. Next. What type should you use to record if it is raining or not? What type should you use to record if it is raining or not?
Boolean.
Same, same.
Boolean, right? Because remember, we only have two answers. So once you have two answers, that is Boolean. So Java uses Boolean for values that are only true or false. What type should you use to represent the amount of money you have? Mhm.
Double.
What about the rest? Think about it. Represent the money you have. Anybody else want to try?
That's an
Should
integer.
we go integer?
Why? Why integer? Why real? Or why double?
Because, like, you could represent the money in decimals, like the cents part,
Mm-hmm.
and you gotta use decimal, so double.
Mm-hmm.
Integers is only whole numbers.
Good. So I guess it would all depends upon the money, but double, like I said, it would all depend upon the money. So let's see. Yeah, double is going to be correct. So the double type can be used to represent an amount of money because we have to take into consideration the cents part. Even though our money does not have cents, um, there still could be a certain fraction of money. Good. So seems you guys have a general understanding now of the data types. Any questions before we continue? All right, so as a recap, remember once it's only whole numbers, we use integer. Once it has to do anything with a fraction or decimal based number, that is real. One single character is a character. Collection of character, a word, a phrase, that's a string. And once you only have two answers, any two answer, once it's two answer, true or false, yes or no, maybe, maybe not, it's Boolean. Good. Now, so we looked at what is a variable, and we looked at the types of variables. Now we're going to be looking at how do we name our variables. Now, you should use meaningful variable names in your programs so that you or someone else needs to, if you or someone else needs to review the logic of the data being processed, then the variables will be easy to remember and understand. So the same thing we would have learned in database, the same principle. That principle is used throughout IT in almost everything that we do. Anything we name must be meaningful, must make sense. We cannot use name something name because we don't know what name we are referring to. You could say F name, F underscore name to indicate first name, L underscore last name to indicate last name. And once again, no space. Same as database, no space. We use either no space or underscore, period, hyphen, whatever the case, but no space. The name must be meaningful, must make sense. Once we look at it, we should be able to recognize it. So we name something VAT. We name it discount. We name it, we can't just say address. We got to break it up also. So the lot, the street, so we can know what parts of the address and so on. So each variable name must make sense when once you look at it. One look at it should be able to tell you exactly what it is. Good. So that is it for variables. That's it for constants. If no questions, We're going to move on to statements and keywords. So, a statement is a description of the processing that can include an action or condition. A statement is a description of the processing that it can include an action or condition. Simply put, a statement tells you what action is going to occur. So it's a description of the processing action, what action is going to be carried out. The statement tells the program what action, what processing action or condition is going to be carried out. So it's basically an action word. It's like a verb. Think of it that way, telling you what is going to happen. Now, a keyword are basically the instructions within the statement. A keyword is an instruction in the statement, once again indicating some sort of action. So keywords are within certain statements. So examples of keywords are input and read. I'm going to keep these two under red because they indicate the same thing. And the rest I'm going to underline with blue because these four indicate the same thing. So input and read are keywords. They indicate that data is going to be placed into the computer. So let me give you an example. Remember, we're looking at how to create an algorithm. And we could say the algorithm is to calculate discounts. So we could say enter the price of the item. We could say that, or we could simply say input price. That's simple. So instead of writing in a descriptive manner, enter the price, type in the price, whatever the case may be, using that keyword input is an indication to the system that you are putting something into the program, that you're about to type something. Or it could be read price, either one. So input price, read price simply means that you're going to enter a value and store it into this variable here called price. So let me continue this line at the top here. Enter the price of an item and store it in the variable price. So this line at the top here in red, enter the price of an item and store it in the variable price, is basically this two word here. That long line is just two words here. Either read price or input price. So read or input is an indication, is a key word, an indication of the action that you're going to enter a value, you're going to type in a value, you're going to put a value into the computer. And you simply indicate where are you going to store this value once I put it in. I'm going to store it in a variable called price. So this is how we would normally indicate input when we're creating a algorithm, a pseudocode. Are we clear in this here?
Yes, sir.
All right. Now the keyword output, display, print, and write, as mentioned, they all indicate you're getting data out of the computer. So we can say input price, and then we can say calculate, price times discount. So that's going to be multiplied, and we can say store it into discount price. So let me take out this calculator. So here we have a calculation, a processing going on. On the right hand side, remember we learned on the right hand side gets calculated. We can say take price, whatever value is put into price, and multiply it by discount, whatever value is in discount, this variable. When you're finished with that, store it into this variable called discount price. Now, you want to see that on the screen. You could type the instruction output or display the value in the variable discount price. Remember, we learned about how to create an algorithm. And in an algorithm, each step tells you what to do. So we could write it this way, once again, output or display the value in the variable discount price, or we can follow the guideline, follow the rule, and use a keyword to basically say output discount underscore price, or display discount underscore price, or write discount underscore price. What was the other one? Print. Print discount underscore price. All indicating the same thing. That you want to output or display the value that was stored in the variable discount underscore price. All of these keywords simply indicate to take the value that was in the variable discount price and put it on the screen. So that's the purpose of keywords, to indicate an action that is going to be carried out. And once again, remember we're learning how to create algorithms. Algorithms are sequence of steps. Step 1, step 2, step 3, and so on. So I could have numbered them because that way I can help keep track. Number them step 1, step 2, and so on. So I know what step is which. And so step 1, enter the price. But as I mentioned, you could write it as A or B. Enter the price of an item, store it in the value, or you can do A or B. Then we carry out a calculation. We multiply price and discount, store it into discount price. Step 3, we output that value, or we could write it as, once again, A, B, C, or D. And as we're going to learn later on when creating pseudocode, this is how we're going to be writing it. We're not going to be writing in a descriptive manner because, as I mentioned, that's more algorithm, writing descriptive. But following the rules of keywords and statements and so on, that's what we're going to be focusing on, how to use the keywords. So, are we clear on all of this so far? Keywords and statements? Are we following?
Yes, sir. Yes, sir.
Amlina, Nathan?
Yes, sir.
Yes, sir. Yes, sir.
All right. Now, another type of statement that we have, it's called the conditional statement. Now, remember we said a statement is basically an action, a description of an action. So, a conditional statement, what action is that describing? Conditional statements allow decisions to be made in a program. This includes deciding which statements are to be executed or carried out. For example, you might want a set of statements to execute only if a certain condition is met. So, a conditional statement makes a decision in the program. If a condition is met, if a certain situation or circumstances is met, then it makes a certain decision. It's similar to, like, when you walk up to a car now. Say for instance you're walking up, well, not on the road, but you're walking up this street here. You're walking here. Now, say for instance you see um, maybe a set of fire over here. For some reason, you have fire over here. Then that condition, you want it to go straight because over here has DQ. So you're walking in this direction here. And the condition is that you want it to go DQ, but a fire for some reason is on the road blocking the path here. What you can do? You can walk through the fire just because you want DQ, or you're gonna stay safe and turn around and go back. That is something what the conditional statement does. If there's a certain condition, if there's a certain situation, it can take different paths in the program. So, for instance, let me give you an example. Um, we can check to see if the day if the day is equal to Saturday. If the day is equal to Saturday, or if today is Saturday, then um, then sleep. Otherwise, else go to school. So if it's Saturday or Sunday. So this is an example here of a conditional statement. If the day is Saturday or Sunday, then sleep. Else or otherwise go to school. Because if it's otherwise, that means it's a weekday, Monday to Friday. So you go to school. So this is the purpose of the conditional statement. It gives you a condition, gives you a situation, and based on the we also call it a criteria, but that's another term you need to remember. Based on the criteria, based on the situation that is going on right at the moment, whatever the value is at that moment, it will take different parts in the program, carry out different actions in the program. All right, are you guys clear now in there?
Yes, sir.
All right, loops or loop statements now. What is a loop? Anybody, what's a loop? Or what does a loop do? When something loops, what does that mean?
It repeats.
It repeats. So a loop is something that repeats, something that goes round and round. So something that goes through the same path over and over. That's what a loop is. It goes round and round, repeating the same path over and over. Now, similarly, if you guys can remember in the previous class, we mentioned that we want to try to limit the number of codes in our program. So imagine the lines as different steps. So we want to limit it. So what we can do is repeat certain steps. So instead of, say for instance, having all of that, we can say in this box here, It has these two lines, and keep repeating it. Keep repeating those two lines, and then continue outside here when you need to come out, basically. So instead of having this here, these two red lines outside here repeating themselves multiple times, keep going down, we keep them inside of an area where we can repeat it over and over as we need it. That's what a loop does. Repeats a certain group of code based on if it needs to be repeated or not. So loops are useful for repeating parts of a program. That is, they will repeatedly execute a section of a program until the end condition is satisfied. In order to exit from a loop, excuse me, you must have a method for checking to see if the task was completed or not. Once a loop terminates, control is returned to the first statement after the block of statements in the loop. So once the loop terminates, control is returned to the first statement after the block of statements. So what does that mean? Well, once again, if we have a program, let's imagine this here is a program. We have the first line of code, the second line of code. So 1, 2. Now we have a loop here. Inside of this loop, we have line number 3, line number 4, line number 5. Now remember, program always goes in order. Step 1, step 2, 3, 4, 5, and so on. And out here, we can have step 6, 7, 8, and so on until the end. Now what the program is going to do is that it's going to start at 1, then reach 2, then enter this loop here at 3. Now when it reaches this 3 here, it's going to repeat inside here like this. 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, and so on. And it's going to keep doing that based on a certain requirements, based on a certain condition. If the condition allows it to stay in the loop, it stays. But once the condition is met for it to exit the loop, what does it do? It comes out of the loop and continues with the next line of code, the next step. It goes to step 6, then step 7, then step 8, and then it ends the program. It goes to the complete end. That's how a loop works. It repeats a certain grouping of code based on a certain condition, a certain requirement. And when that loop finishes, it continues the program with the next logical step, whatever step comes next. Are we clear on this here?
Yes, sir.
All right. We're actually going to go more in detail for conditional statements. There's a whole chapter on these here, loop statements and so on, like how to actually make use of them. So it's just to understand what they do for now. All right, so our next term that we're going to learn about, what is a subroutine? So for big programs, it is easier to work on small sections by separating the algorithm into individual sections. So you had a large program like this here, and instead of you working on it as one large program, you break it up into parts. This is part A, this is part B, part C, D, and part F. So you break it up into parts. Now these parts or sections are known as the subroutines or functions or modules, or procedures. Those four terms refer to the same thing. Breaking a large program into parts, into sections, subroutines, functions, modules, or procedures. Taking a large program and breaking it into parts. Now, a subroutine is a named section of a program that can be repeatedly called on to perform a given set of instructions. So, not only is it useful because you can say there's two reasons why we would break a large program into parts. There's two reasons. The first reason is so that we can divide the work. So for instance, we can say, Africo, you do part A. Amlina, you work on part B. Nathan, you work on part C. Oceano, you work on part D. Stephanie, you work on part F. So that way now, you don't depend upon one person to do everything. You allow the work to be managed by different persons. Each person will perfect his part, ensure it is working, and then they come together and join it together, join the program together. That's how programming works today. Because each of it should be able to work on its own. Africa Spark should be able to work on its own. Amlina, Nathan, Oceana, and Stephanie. All the parts should be able to work individually. So when you join them together now, you get a whole program. So that's one reason why we separate them, break it up into parts. Now, the next reason why we break it up into parts is in relation to loops. We can repeat a certain part of the program. We can repeat a certain section. So, say for instance, this is the direction of how the program is going to run. Part A is going to run, then B, then C, then D, then F. Say for instance, next you want part C to run. Then all you have to do is copy the code from part C and put it at the end. Or you say at the end here, now copy it. Look back at this part here, at this section, and repeat that part. Then next, repeat part D. Then repeat F, and then end the program. So that's another usefulness of sectioning of the program. It's to manage the program and also to repeat certain sections or parts of the program. So sometimes it returns information to another part of the program, such as accepting a number between 1 and 5, and then returning the corresponding day of the week. Other subroutines might carry out instructions such as printing the headings of an invoice. So one subroutine might be for input, another subroutine might be for processing, another subroutine might be for the output, another subroutine might be for the storage, could be something like that. Another subroutine could be processing part 2, processing part 1, because remember the processing could be the technical parts. So they break up the different functions into parts once again. Now using subroutines saves writing the same code several times in the program. As mentioned, you can repeat the different parts of the program. So you don't have to type it over and over again. You simply say use back that section. This method of focusing on the program's goal and then separating the program into manageable components is called divide and conquer, or the top-down design. So instead of, once again, one person doing everything, we call it the divide and conquer method. You give each person a particular task to do, each person will comfortably work on that task, and then we get a final result. So the individual subroutines can be tested in isolation to check that they are that they correctly perform their function. So we check each one of the subroutine, make sure each one is working individually, working correctly. All right. Any questions on subroutine?
No questions, sir.
All right. All right. Let me to wrap up today's class. I don't want to go over to the next chapters yet. To wrap up today's class, let's look at these questions here because I'm slowly losing my voice. Um, so the first question: state whether the following statements are true or false. So an algorithm can be written as a pseudocode. True or false?
True.
What about the rest? True or false?
True.
True. An algorithm can be written as a pseudocode. Good. B. An example of pseudocode is a flowchart.
False.
False, sir.
Right. Because it's an example of a algorithm, not a pseudocode. Good. Flowcharts use English type statements, sentences.
False.
False.
Good. Flowcharts use specific symbols.
True.
True. So symbols, diagrams, basically the same thing. A flowchart can be developed into an algorithm.
True.
Mhm.
True.
True. Or would that be false? Because technically it's supposed to be an algorithm into a flowchart. Let me confirm. Doo-doo-doo-doo. Yes, this can work in this direction also. Good. Question 2. Explain the purpose of a variable.
A variable is used when you don't want to have one recurring value over and over, like a range of options.
Mm-hmm. Good. Anybody else? A simple explanation. What's the purpose of a variable? As simple as possible. 2 words.
Store information to the reference.
Right. It's to store information, to store data. That's simple. And as Africa said, the variable changes. Well, that answers the second question. Explain the difference between a variable and a constant. Anybody want to give an example, a scenario of question 3? We know the answer, but give an example for it. What example could we use for a variable and a constant? Nothing. Not even the example I use. What was the example I use?
Sir, the constant would be the VAT and the variable would be the items in the store.
Very good. So the value that you do not want to change, the VAT, the discount, and the value that does change, which is the different prices of item. Good. State the most suitable data type for each of the following. The current year. What data type?
Integer.
Integer, sir.
Integer. Good. Because it's a whole number, right? Somebody's height.
Real or double?
Real. Because that's going to be a decimal base number. Now, this one here, somebody's phone number. Before you answer, think back to database. What I would have told you. What data type will it be?
Wait, did you say that it has to be separated into parts?
Mm-hmm. Yeah, what data type would you guys put for a number, phone number? There's only five options you got. Integer, real, character, string, boolean. Which one? Nobody?
Sir, string,
And why string?
because the thing I have to say is like different data or like different, you have to separate them.
Mm-hmm.
So string is like multiple different data, like information.
Yeah. So the correct answer is string because two reasons. One, there is no reason for you to calculate a phone number. And two, remember you have to add symbols. You have to add the bracket, the hyphen, your plus sign, whatever the case may be. So you cannot use a number data type. So the same rule I would have told you guys, majority of the rules that I would have told you guys in database, it applies to programming also. So what data type for night or day?
Boolean.
Boolean. Two answers, right? Your blood type.
String.
Why not character?
There isn't character, just yes, yes. It could be characters because it's just a single character.
But can we use character?
I was thinking because you would say type A or type B is going to be string and not
Mm-hmm.
character.
That's another reason. Anybody else figure it out? Character or string? Which one?
String?
And why string?
Because you gotta add the letter and then the negative or positive sign.
Exactly. So even though it is a letter, type A, type B, type O, or whatever, There's also O positive, B negative, whatever the case may be. So it has to be a string. Good. And the final question. For each of the description in question 4, suggest a suitable variable name to store the data. So what would be a suitable variable name for A? A suitable variable name for A.
So current year,
Yeah, because remember it has to represent exactly what data is going to be stored. So current year is going to be used. Is that current year with a space or without a space?
without a space.
Right. B. What variable name can we use? So current.
For B, I think you could probably give the person, like, call them person one and say person one height.
No, when you're storing those things, you only basically use one variable for everybody.
You just say person height.
Person height. Or you could simplify it and just say height. So normally when we're storing data, even though height, price, or whatever is going to be different for various items, different persons, or so on, that one variable is actually being used for everything. Because remember, it's a variable. It's going to change for the different item, for the different person, and so on. Good. What name would we create for a mobile phone number? What variable name?
Mobile phone number.
Mm-hmm. Also, another rule. Remember, we set some rules for naming variables. Um, you want to be meaningful. You want to have no space, but at the same time, we don't want it to be too lengthy because we don't want to be typing too much. So in this case here, we could shorten it to mobile number, and certain words you can shorten. So you could do M underscore number, thus making it shorter. Um, D, what variable name can we use there?
Blood type.
For D?
Yes, sir.
For D?
Wait, D? Oh, I said, I heard E.
All right, give me one for D.
Time of day.
Time of
Time of, yeah.
time of day, or we could just simply say day, and the answer of yes or no would indicate that, and then blood type here. Good. So remember the 3 rules for naming a variable. All right. So to recap, what we looked at today. Um, Let me look back at the Word document. Take out draw. So remember we looked at reviewed what is an IPO chart. We reviewed what is the difference between a flow chart and a pseudocode. Then we looked at how a computer works with the memory, the RAM, and how we input data, it processes it, and so on. Then we looked at how to use a variable, how to use a constant, how to use the various keywords, what is a loop. So we looked at what's the difference between a variable and a constant, what are the different data types, how to name the variable, the tree rule, no space, meaningful name, not too lengthy, but not too short at the same time. Also, a variable should not start with a number. So should never start with a number. So that's your fourth rule. So never start with a number. Um, as you remember other rules, I'll let you know. Um, what else? And then we looked at what is a statement, what is a keyword, conditional statement, what is a loop, what is a subroutine, and so on. Any questions before we close?
No, sir.
All right. If no questions in today's class, that will be the end. Enjoy the rest of your day.
Thank you, sir.